Code page 437 is the character set of the original IBM PC, or MS-DOS. It is also known as CP437, OEM 437, PC8, or MS-DOS Latin US. The set includes ASCII codes 32 €126, extended codes for accented letters, some Greek letters, icons, and line drawing symbols. It is sometimes referred to as the OEM font, or High ASCII, or as extended ASCII. In a strict sense, this character set was not conceived as a code page. It was simply the graphical glyph repertoire available in the original IBM PC. This character set remains the primary font in the core of any EGA and VGA-compatible graphics card. Text shown when a PC reboots, before any other font can be loaded from a storage medium, typically is rendered with this code page. Many file formats developed at the time of the IBM PC, such as NFO, define this as the default encoding. Display adapters, the code page stored in RAM is also called the hardware code page. In Western PCs it typically defaults to code page 437, but various Eastern European PCs used a number of other code pages as hardware code page, sometimes user selectable via jumpers or CMOS setup. Arabic and Hebrew PCs and printers even supported multiple software switchable hardware code pages, also named font pages. The original IBM PC contained this font as a 9A, 14 pixels per character font stored in the RAM of the IBM monochrome display adapter and an 8A, 8 pixels per character font of the color graphics adapter cards. The IBM enhanced graphics adapter contained an 8A, 14 pixels per character version, and the VGA contained a 9A, 16 version. All these display adapters have text modes in which each character cell contains an 8-bit character code point, giving 256 possible values for graphic characters. All 256 codes were assigned a graphical character in ROM, including the codes from 0 to 31 that were reserved in ASCII for non-graphical control characters. ALT codes, a legacy of code page 437 and other DOS codexes, is the set of number combinations used in Windows ALT key codes introduced in the first versions of MS-DOS. The user could enter a character by holding down the ALT key and entering the 3-digit decimal ALT key code on the numpad. When Microsoft switched to more standard character sets in Windows, so many users had memorized the numbers used by their DOS codepage that Microsoft had to retain the original codes. Characters, the following tables show code page 437. Each character is shown with its equivalent Unicode code point and its decimal code point. See also the notes below, as there are multiple equivalent Unicode characters for some code points. The decimal codes are also known as ALT codes. Although the RAM provides a graphic for all 256 different possible 8-bit codes, some APIs that ostensibly support code page 437 will not print some or all of these code points, in particular the range 1 to 31 and the code at 127. Instead they will interpret them as control characters. For instance, the BIOS on the original IBM PC has a character output command that would interpret the codes for CR, LF, BS, and some others. Code 26 could not be stored in MS-DOS text files as it indicated end of file. Many printers were also unable to print these characters. Implementers of translation to Unicode should note that these codes do not have a unique, single Unicode equivalent, and the correct choice depends upon context. 0 and 255 both draw blank space, as does 32. The use of 255 for U+00A0 non-breaking space has some precedent in word processors designed for the IBM PC. 225 is both the German sharp S and the Greek lowercase beta. 227 is the Greek lowercase pi, but early fonts such as Terminal use a variant of pi that is ambiguous in case, and therefore can be used for the Greek capital Pi or the inner product sign. 228 is both the inner summation sign and the Greek uppercase sigma. 230 is both the micro sign and the Greek lowercase mu. 234 is both the ohm sign and the Greek uppercase omega. 235 is the Greek lowercase delta. but it has also been used as a surrogate for the Icelandic lowercase eth and the partial derivative sign. 237 is supposed to be used as Greek lowercase phi, but is mainly used as the empty set sign and was also used as the Greek phi symbol in italics to name angles, diameter sign, and as a surrogate for the Latin lowercase o with stroke. 238 is both the Greek lowercase epsilon and the element of sign. Later it was often used for the euro sign. History: the repertoire of code page 437 was taken from the character set of Wang word processing machines, according to Bill Gates in an interview with Gates and Paul Allen that appeared in the 2 October 1995 edition of Fortune magazine. We were also fascinated by dedicated word processors from Wang, because we believed that general-purpose machines could do that just as well. That's why, when it came time to design the keyboard for the IBM PC, we put the funny Wang character set into the machine smiley faces and boxes and triangles and stuff. We were thinking we'd like to do a clone of Wang word processing software someday. The selection of graphic characters has some internal logic. Table rows 0 and 1, codes 0 to 31, are assorted dingbats. The isolated character 127 also belongs to this group. Table rows 2 to 7, codes 32 to 126, are the standard ASCII printable characters. Table rows 8 to 10, codes 128 to 175, are a selection of international text characters. Table rows 11 to 13, codes 176 to 223, are box drawing and block characters. This block is arranged so that characters 192 to 223 contain all the right arms and right filled areas. The original IBM PC MDA display adapter stored the code page 437 character glyphs as bitmaps 8 pixels wide, but for visual enhancement displayed them every 9 pixels on screen. This range of characters had the 8th pixel column duplicated by special hardware circuitry, thus filling in gaps in lines and filled areas. Table rows 14 and 15, codes 224 to 255 are devoted to mathematical symbols, where the first 12 are a selection of Greek letters commonly used in physics. Characters 244 and 245 are the upper and lower portion of an italic long S, the symbol used as the integral sign, and they can be extended with the character 179, the vertical line of the box drawing block. Character 244 could also be used as a surrogate for the angstrom character. Characters 249 and 250 are almost indistinguishable, the first is slightly larger than the second, which resembles the typographic middle dot. The character 255 is merely blank, and acts as a kind of non-breaking space in order to arrange math formulae. Most fonts for Microsoft Windows include the special graphic characters at the Unicode indexes shown, as they are part of the WGL4 set that Microsoft encourages font designers to support. To draw these characters directly from these code points, a Microsoft Windows font called Miss LineDraw replicates all of the code page 437 characters, thus providing one way to display DOS text on a contemporary Windows machine as it was shown in DOS, with limitations. Internationalization. Code page 437 has a series of international characters, mainly values 128 to 175. However, it lacks several characters important to many Western languages, Spanish, French, Portuguese, and Catalan. German sharp S shares its code point with the beta symbol, which is acceptable at the low resolution on the original IBM CGA hardware, but unacceptable at higher resolutions. Most newer glyph sets for code page 437, including those built into the IBM EGA and VGA graphics cards, prefer the German sharp S shape for this character. Scandinavian lacks /OA and A. Character number 237, the empty set symbol, could be used as a surrogate, but its spacing is awkward for display within a word. To compensate, the Danish, Norwegian and Icelandic code pages replaced cent mark with A and yen with A. Most Greek alphabet symbols were omitted, beyond the basic math symbols. Along with the cent, pound sterling and yen yuan currency symbols, it has a couple of former European currency symbols, the florin and the peseta. The presence of the last is unusual, since the Spanish peseta was never an internationally relevant currency, and also never had a symbol of its own. It was simply abbreviated as PT, TA, PTS, or PTAS. Spanish models of the IBM electric typewriter, however, also had a single position devoted to it. Later MS-DOS character sets, such as code page 850, code page 852 and code page 737, filled the gaps for international use with some compatibility with code page 437 by retaining the single and double box drawing characters, while discarding the mixed ones. All code page 437 characters have similar glyphs in Unicode and in Microsoft's WGL4 character set, and therefore are available in most fonts in Microsoft Windows, and also in the default VGA font of the Linux kernel, and the ISO 10646 fonts for X11. See also, ALT codes, ANSI, ANSI art, ASCII, ASCII art, and FO file format, which uses CP437, semi-graphical characters, Western Latin character sets, terminal, nibble, dwarf fortress. References, OEM 437. Go Global Developer Center. Microsoft. Retrieved September 22, 2011. ABOEM font. Encyclopedia. PCMAG.com. Retrieved November 15, 2011. Code page 437 milliseconds DOS Latin US. Developing International Software. Microsoft. Retrieved November 14, 2011. Systems available in Eastern European, Arabic, and Asian countries often use a different set. The designation OEM, for original equipment manufacturer, indicates that the native hardware character set supplied in ROM could be changed by the manufacturer to meet different markets. 00437. Code pages by CPGID IBM. Retrieved November 14, 2011. CP437 DOS Latinus to Unicode table. The Unicode Consortium. Retrieved November 14, 2011. The Unicode Consortium, the Unicode Standard 4.0, Chapter 7, European Alphabetic Scripts, P176. PDF version, Richard Wilton, Programmer's Guide to PC and PS/2 Video Systems, 1987, Microsoft Press. Staff. Misline Draw, version 2.00 inches. Microsoft. Microsoft Corporation. Retrieved July 1, 2012. Staff. WD97, misline draw font not usable in Word. Microsoft. Microsoft. Retrieved July 1, 2012. External links, IBM code page 437 reference chart, IBM PC memory mapped video graphics to Unicode on official Unicode site.